also known as Mike. Welcome back. This video is going to be a bit different because I'm going to be talking about a specific technical issue and how to do something. And that technical issue is how to use the Nerdseq as more of a musical instrument by adding input devices to it. What is a Nerdseq, you ask? It is a tracker, also known as a sequencer, and it is for controlling a modular synth. It is sort of a composing instrument for modular synths where you can compose sounds but also play it just like an instrument if you have the right tools, if you have the right input devices. Now, I saw a YouTube video where the creator of Nerdseq demoed how it can use a faderbank. And this here is a faderbank. It allows you to move sliders up and down, and you can use it to control almost anything within the Nerdseq, like Euclidian drum beats and tempos and sound envelopes. I mean, pretty much everything. It's perfect for music makers. But the Nerdseq is also known as the most powerful tracker sequencer, not the easiest to use. With that power comes complications. I spent the time figuring out the details on how to hook up a faderbank to the Nerdseq. And this video is about making it easy for other people to achieve the same functionality so that musicians don't have to deal with the technical details of doing this. And it's actually quite simple if you know exactly what to do. I want people to spend more time creating music as opposed to just overcoming technical details. So here we go. I'm going to show you how this can be done, how you can hook up an input device to the Nerdseq if you only have like one or two devices. This is the Nerdseq, and there's 4 inputs here. Those inputs are used for like clocks or some kind of triggers or input devices. The problem is that you're limited to just 4 inputs, and there's no expanders for that. I'll show you an example of how you hook up one device. So we have this slider here. I'm just going to hook up the output of the slider to the input of the Nerdseq. Now we're going to create a mapping. You map basically inputs into certain parts of the Nerdseq. And so I'm going to go to the project mapping setup. I'm going to create that mapping. I want CV input. So say CV and which input? Well, input 1, yep. And there's nothing to put in the third column here. And what I'm going to do is, just to show you how this is done, is I'll change the global tempo. And so I'll select global, and that's transpose, that's global swing, and here's tempo, or the beats per minute. So that's all I need to do. And now you can see at the top here, it's showing the hexadecimal value or the decimal value of the input. And so now when I move the slider, you can see the main window here for the sequencer. When I move the slider, you can see that the beats per minute is actually changing. This allows me to do is to change the tempo just by moving finger here. And that's kind of cool because you want to speed up, you can just move finger up a bit, slow down, you just move down a little bit. What we're going to do now is hook up the faderbank to the Nerdseq to show how we can actually have 8 inputs. What we're going to do now is hook up this faderbank to the Nerdseq. And how the faderbank can communicate with the Nerdseq is through this separate bus called I2C. Use this kind of cable here that goes behind it. So basically what we're doing is we're kind of patching this faderbank to the Nerdseq. So the Nerdseq, a standard Nerdseq, doesn't have hardware in order to handle the IC2. You need this separate module here, which is an expander for the Nerdseq. It actually allows you to do MIDI, I2C, you can hook up keyboards and do other things. And there's also this knob here for editing. What I'm going to show now is how to actually configure this so that way you can get things to work. Now, the first thing you need to do is on the back, move a jumper cable because there's pull-up resistors for these I2C bus. Jumper cables are set for if you don't have anything connected at first. And so what you need to do is you pull out this blue tab here and you move it inwards to where it says 5 point something. And this is to channel A. You don't need to worry about channel B at all. And now I can actually hook up this device to power and to the Nerdseq. Yeah, this is a power cable, and on the back here I can see that the power bus is on the bottom. Yeah, it's nice and easy. It's just like other modules. And then you need to hook up this Nerdseq cable. This is actually, I'll flip this around here. On the back here, there's a few cables. And what we're going to do is hook it up to the, where is it, the MIDI one. This one right here, it says pad MIDI. So I'll put this back, and that is this cable here. and that goes right to where it says MIDI bus. And now we need to hook up this wire here to the Nerdseq IO device. And the important thing here is to get the wires connected properly here. So see, dark blue is the one on the end here, and I will connect that. It says, barely read it, but there's ground here. Okay, so the main thing to remember is that dark blue here is going to ground. So I can put that in. And I will slide this cable on the other side. The reason is I want the faders to be on the right-hand side because I'm right-handed. Now I will plug in the dark blue side, which is the one on the right there. Okay, so this is the I2C connector. And again, dark blue is connected to ground, if you can kind of see that there. Okay, so actually need power for this guy too, of course. And a nice thing is that it says either way. Somehow it says that. Oh yeah, either way. And so you don't have to worry about which direction the cable goes. Actually, let's put it in this way. You can kind of place it in here. And in fact, I could just go ahead and turn this on, but it's not going to work. And this is one of the little secrets about this. And it's more than just like putting the module backwards. It is because we need to configure the fader bank. There's this hidden connector here, this really odd looking thing right there. You have to look up, well, what kind of cable is that? And it turns out it is a USB micro device, and not to be confused with a USB mini. So lots of different things. Fortunately, I did have a cable for a bicycle light. So what I'm going to do is I'm going to hook that up. Okay. And now I can actually turn this on. And you can see, oops, you can't see that. These have lit up, but they're not actually going to do anything. There's no communication. And the way you can tell if there's communication is that in this device, the LED for the I2C communication will light up if communication is successful. But when I'm moving these things, it's not, because it's not configured. Okay, now that I've got the cable plugged in to the fader, I'm going to plug the other end. It's just a regular USB cable, of course, and I'll just plug that into my Mac laptop that I'm using. So they're the ones who make this fader that I'm using, and they have the sort of instructions for how to configure this. Go to the bottom here, and it says download the new firmware. I don't actually want to download the firmware, but what I want to do is use this online parameter editor. Click on that. And up comes this window. I've turned on the power to the device, so I plugged in USB, and hey, it comes up. So through your web browser, you can actually talk to the device and configure it. That's pretty cool. I think if I move the faders, oh yeah, you can actually see them move up and down and things like that. So that's pretty cool. But what I want to do is edit the configuration. Yeah, say edit config, and then I have to click on device options. So it's kind of hidden within here, and there's some options that you don't really care about. You need to make sure that the boot delay is significant. I think sometimes the default is 1 millisecond, but you need to give the Nerdseq this device time to boot up. So 100 milliseconds seems to work fine. This is the one most important thing, because we're using I2C for communication. We have to make this device a leader instead of a follower. So it is the fader bank is going to control the Nerdseq. So the fader bank is going to be a leader. So that's the main configuration thing here. And so once I set that, then I just click on update controller, and done with the hardware. So I am going to just disconnect the USB cable, and I will place it within the rack, and I'm going to screw it in now. Now that we've got the hardware set up, we have to actually configure both the multi-IO module and also a few other things in order to get the fader fully talking to the Nerdseq. So first of all, let's get the IO thing configured. And so there's no lights on right now if I press this, and that's because the multi-IO is not actually configured. The way you do that is it's in setup, so that is shift setup, and MIDI expander. So right now it's set to the default, which is TRS-A, and what we need to do is just set it to multi-IO. That should do it. Now I can go back to pattern screen, and hey, when I press on the buttons here, it actually works. So that means the multi-IO is actually working. And to show that it is receiving information, I'm going to move a fader, and you can see here that the communication LED is lit up. So now the information is getting to the multi-IO, but what we need to do is make use of it within Nerdseq. This is going to be configuration within the project. And one thing to remember with the project is that if you don't save it, it goes away. What you most likely want to do is after configuring your project is to save it as a template. And that way you can always load in this basic configuration. Otherwise, it will indeed go away. Now we need to configure the second part of things. We need to configure the actual Nerdseq in order to receive the information from the multi-IO and do something with it. So what I'm going to do is hit the project button, and then need to go to MIDI I2C setup and click on OK. And we get a menu here for MIDI I2C setup. And the mysterious thing here is that you don't see anything for I2C communication. You think that, oh, are these dots it? Maybe need to create something here. It turns out that's not it at all. You just scroll down and it's hidden down here. No, not here. These are record parameters. But here we go. Okay, so this is I2C configuration. And what we need to do is we don't care about the address because the default of 31 is fine, but we have to enable it. So we have to turn the mode on. And what I'm going to do is select the very first one here. And what this is for is it's saying that a fader, basically a 16N I2C, that's what faders are called, it's a little cryptic, is going to push information to the Nerdseq, and that is the NS. And it's saying that it's going to do it for 1 to 16 channels. And even though I only have a fader bank that has 8 channels, if I go further, you can see that, yeah, you can add more channels here, and there's other things, other devices you can integrate to. But all we need to do is deal with 16N into the Nerdseq. Then I'll hit project again, so that should be set up. And now what I need to do is I want to actually configure track information because I want to show you some things in the drum machine. And I will select track assign here, and I'll say for track 6, let's switch it to trigger 16 output. What this is going to do is it will give me, for track 6, it'll give me the special drum page. And that's really good for demonstrating what you can do with Euclidean beats. So that's all set up. I'll go back to project here. So now, and then all the configurations will be set up properly. So I can, okay, I'll hit template. And I believe with a multi-IO expander, I could actually use a keyboard for this, but I'm not going to. Oops, wait a second, I didn't quite do it right. Okay, we're going to call it template, say ready. Okay, so it is saving configuration into template project. And now if I look at sequencer, actually doesn't even tell you the name. Oh no, it does. It shows here that it's a template here. So that's handy. Okay, now what I want to do is do mapping. And so the way you have input devices hook up into the Nerdseq is by mapping them. So you can map any input into anything. First, what I'll do is I'm going to deal with a slider. So we're going to say go back into project, go back, find mapping here. Okay, so here is mapping setup. And click on OK. And now what I can do is tell this particular input to write to something, and I'm going to have it actually control the tempo. I will, oops, let's see. One thing is you can use a scroll, you can use the knob here to select things. And so I can say, which one is it here? IC2. And then SCCV, it means, well, that's what it always says there. And then I'm going to tell it for the very first one, which is the number 0. Yeah, so that's this one here. And so now notice that when I move this slider, not only is the light coming on showing that there's communication, but up here you can see that the value of the input is being updated here, showing that, yeah, really communicating with the system. And now what we can do is we can point this slider to something. Again, I will go to global, and tempo. Yeah, so it says global beats per minute. So now I have this mapped, and so that's really nice. What I should be able to do is go back to pattern here, and you see beats per minute, it's 128. If I move the slider, It's actually setting it. See, this fader outputs 0 to 10 volts. That means that the beats per minute can go to its maximum value, which is 500. Of course, that's kind of absurd. And it can start at 1. So what you could do is you could also modify the mapping so that way you have a reasonable range and you're not going all the way from like 1 beat per minute to 500 beats per minute. But you can figure that out on your own. Now what I'm going to do is hook up these other faders, these 3 faders here, in order to do Euclidean beats. Let's go back to mapping here. Say OK, and I'm going to go down here. I'm going to skip a line just to kind of separate things out a little bit. So now I need to say which fader. So say use the one that's connected using I2C, yeah, and then so that's fader 1, which is actually the second fader, nice and cryptic. And now what I'm going to do is push it to the track 6 Euclidean value. So I can go to trigger track, okay. And then I can go to track 6. Okay, so now there's a whole bunch of destinations for a track. And so it's nice to have this wheel here in order to find the right one. And so I'm looking for Euclidean, oh yeah, here we go. Okay, so it's saying that it's going to go to the drum matrix to Euclidean 1, which is what I want. Now I'm going to go do another one. Okay, and then I'm going to make this go to second Euclidean track. Let's see, track 6. There we go. Okay, one more just for the heck of it. Maybe I should do 2 more so that we were actually using 5 inputs. Okay, so now I have set these up. So what this means is that all of these faders are mapped to the drum matrix. And I'm going to show you the drum matrix. I need to set up the track 6. Okay, so go to project. I thought I did this, but we're gonna figure it out again. Oh, okay, so it's not, yeah, so the track is not set. Okay, so this is going to output track 6 to trigger 16, and this will allow me to show you the drum matrix. What I need to do is read the instructions here, which says that for this particular window, it's not consistent. So once you set things, you have to go to set and then hit OK. And so that's unfortunately not a consistent interface because most of the menus, you could just like exit the menu and it remembers. Unfortunately, this one does not. So hit OK. And OK, so now I can go back. Here, I will hit OK to create the pattern again. Go inside the pattern. And this time, the pattern looks different because it's showing a bunch of triggers that can be set. And if I go all the way to the end here, this is down here, you can see it's called the drum matrix. Now, if I move a slider, whoa! So what this is doing is it's distributing beats. It's distributing beats based on the slider. So what I'm going to do is just give it something reasonable here. I can set the second one, now the third one. And notice that these are all like a little off, so it can make for more interesting patterns. If I hit start, it actually starts playing it. You can actually see the triggers here. They're lighting up, and that's indicating it's actually working. We've got this all set up. I'm going to show you what kind of sounds it can make. On the right here, I have a sampler, basically. It's called the Bitbox Micro. It has some sounds loaded into it, like a gong, things like that. I am going to hook those up. I have the Nerdseq talking through this expander to the Bitbox. And so it's talking to the sampler. And so now when I hit start, you actually hear the different rhythms there. If I slide the first slider up, it'll go faster. And so notice the clock here is also going faster or slower. And the cool thing is that when I adjust these, it's changing the Euclidean rhythms. And you can hear the interesting patterns that it makes, because Euclidean rhythms are a great way of kind of distributing beats up into a way that's, to us Westerners, it's kind of unexpected, but it turns out a lot of music from other areas of the world are based on this. And so now you have these sliders affecting the drum beats and the speed. And that's really amazing. And we still have a few sliders left, and we still have the 4 CV inputs left to add other input devices. It's not that difficult. There's just a few little complications of getting this all to work. The main thing is that the Nerdseq really is powerful. It's really cool how you can hook up a lot of input devices to it. That's it for now. Talk to you soon.